Hello students, I hope you all are doing well. Let's start today's lecture which is about the continuation of the previous lecture which is the quadratic equations. Okay, in that let's start this lecture with the problems. Okay, let's solve some problems. First of all, listen here. This quadratic equation is arises in several situations in the world around us. Okay, in the world around us, and in the some fields of the mathematics also. Okay, so let us see some of the situations where we can apply this quadratic equation. Okay, let's see those. Okay, the first one is here is the first one, that is John and Jivanti together have 45 marbles. Okay, John and Jivanti together have 45 marbles. Both of them lost 5 marbles each. Okay, both of them lost 5 marbles each, and the product of the number of marbles they have now is 124. We would like to find out how many marbles they had to start with. They had to start with. Okay, let's understand this statement or a given situation. Okay, first of all, what is marbles? What is marbles? Can any one of you guys play marble games? Okay, marble games. So what is? Did you see the marbles? So these are the marbles. See, these are the marbles. Here, there is a two persons with person, which is the first one is John and Jivanti. John and Jivanti. Okay, these John and Jivanti together have 45 marbles. They together have 45 marbles. Okay, and both of them lost 5 marbles. Both of them lost 5 marbles. That is minus 5. Okay, each person lost 5 marbles. Okay, and the product of the number of marbles they now have is 120. So the product of the marbles they have now is 120, which is equals to, we can write it here, that is 120. Did you understand? Okay. We would like to find out how many number of marbles they had to start the game. Okay, we have to find how many marbles. With how many marbles they are going to start the game. Okay, let's start. Okay, we understand the situation here. Okay, let's solve this to get the quadratic equation. Okay, okay. Uh, let's take let's take the number of marbles John has is x. Why I took x? Because we don't know the particular number of marbles that John had. Okay, the particular marbles that John had, we don't know. So that's why I took that x. I take x and say the number of marble Jivanti, the number of marbles Jivanti has, I will take 45 minus x. Okay, the number of marbles John has is x, so the total number of marbles is 45. 45 minus x is the number of marbles that Jivanti has. You understand? Okay, let's continue. Now, the number of marbles John has when he lost 5 marbles. When he lost 5 marbles is what is x minus 5, right? And the number of marbles Jivanti has when she lost 5 marbles is what? That is 45 minus x minus 5, okay, which is equals to 40 minus x, right? 45 minus 5 is 40 minus x. Now the and here when you see this, the product of the number of marbles they now have is 124. Okay, let's write that. The product of these two persons, that is John and Javanti, as is the number of marbles that John has, is Jivanti had now is, that is 40 minus x, right? We have to do product here. They given the product of the number of marbles they have now is 124, which is equals to 124, right? Okay, let's multiply these two terms. We get 40x, right? 40x, x into minus x is minus x squared, minus 5 into 40 is minus 200, minus 5 into minus x is plus 5x, which is equals to 124. Okay, now here we have 40x and 5x. We can add both, right? So minus x squared minus 200 plus, when we add this, we get 45x, which is equals to 124. Okay, and then here also we have constant. Here also we have, in the RHS side we have constant. So I will shift these whole LHS to the RHS. Okay, then we get 0 is equals to 124 plus x squared plus 200 minus 45x. The signs are changed, right? When I move this LHS to RHS, move or shift this terms to the RHS. Okay, now 0 is equals to, let's add these two constants, okay, because there is a plus signs before that number. So when we add, we get 324 plus x squared minus 45x. Okay, now I will arrange it in the quadratic form. Okay, quadratic equation form. Now we can write x squared minus 45x plus 324, which is equals to 0. So finally we get the quadratic equation. So therefore this is the required quadratic equation. This is a required quadratic equation. Finally, by analyzing the given situation, we are doing the quadratic equation. Finally, we get the quadratic equation. Okay. So this is what the first problem. Let's continue with the next problem, that is second problem. Okay. What is the second problem? check whether the following are quadratic equation or not. Okay, that is they given the equation. Let's check it. Okay, whether it is a quadratic equation or not. Let's check. First of all, we have to here we can apply the a minus b whole square formula. So let's apply. When we apply the a minus b whole square formula, we get ex square uh, minus 2x into 2 plus 2 square plus 8 is equals to 2x minus 3, right? And then we get x square minus 4x plus 4 plus 8 is equals to 2x minus 3. So x square minus 4x plus 12. 4 plus 8 is 12. So 12 is equals to 2x minus 3. Then when I shift this x to, okay, when I shift this RHS to LHS, we get x square minus 4x plus 12 minus 2x plus 3 is equals to 0. Then x square minus, here there is 4x minus 4x and minus 2x, so we get minus 6x, and here we have plus 12 and plus 3, so plus it will become plus 15, which is equals to 0. So is this a quadratic equation? Yes, right? This is a quadratic equation. Finally we get the quadratic equation. So when we check this equation, we know that this is a quadratic equation. Okay, so this is what the second problem is. Okay, let's move to the next one. Okay, let's move to the next concept, that is the solutions of quadratic equations by factorization. Okay, let us consider an equation, quadratic equation here, that is 2x squared minus 3x plus 1 is equals to 0. It is a quadratic equation. When I take x is equals to 1 for this quadratic equation, when I replace x by 1, we get 2 into 1 square minus 3 into 1 plus 1 is equals to 0. Now 1 square is 1, 1 into 2 is 2, minus 3 into 1 is 3, plus 1 is equals to 0. 2 plus 1 is 3, minus 3 is 0 is equals to 0. So by considering this, we can say this 1 is the root of this quadratic equation. This 1 is the root of this quadratic equation. Okay. When I take a polynomial, not a quadratic equation, a quadratic polynomial. Okay. By considering this quadratic polynomial, I will take x is equals to 1. Then I get, when I replace this x by 1 in the quadratic polynomial, we get 0. Right? So, by considering this, we can say that this 1 is the 0 of the quadratic polynomial. Okay, this 1 is the 0 of the quadratic polynomial. Okay, in general, we take the root as alpha. In general, we take the root as alpha. That is, we can take 2 alpha square minus 3 alpha plus 1 is equals to 0. Okay, where x is equals to alpha. Right? This x is a root, right? So in general, we consider alpha is a root of the quadratic equation. Okay, do you understand? Okay, let's solve some problems now. Okay, let's solve. The first problem is, take down the first problem, which is find find the roots of the following. Roots of the following. Okay, the first problem is, okay, roots of the following, by using, we have to take that also, by using factorization method. By using factorization method, let's take the quadratic equation, that is 2x square plus x minus 6 is equals to 0. 2x square plus x minus 6 is equals to 0. Let's solve this quadratic equation. Here there is a coefficient for x square, right? So we have to multiply these 2 to 6 to get the factors, right? So minus 6, there is a minus 6 into 2 is minus 12. We have to take factors for minus 12 to get x. Okay, so 4 3s are 12. We have to take here minus, so that we get the, when we split this x, we get plus 4 and minus 3x. So we can write 2x square plus 4x minus 3x minus 6 is equals to 0. Okay, now let's take, let's write here. Now we can take 2x common, right? So 2x, when we take 2x common, the remaining is x plus 2, right? X plus 2, and also we can take here 3 common. When we take minus 3 common, we get x plus 2, right? Minus 3 common, when we take minus 3 common, we can get minus 3 into x plus 2, which is equals to what? 0. Okay, now let's take x plus 2 common, right? X plus 2, if we take x plus 2 common, we get 2x minus 3 is equals to 0, right? Then we can equate this 2x plus 2 is equals to 0 and 2x minus 3 is equals to 0. We get x is equals to minus 2 and this 2x is equals to 3. This minus 3, when we shift to RHS, it will become plus 3 and x is equals to 3 divided by 2. Okay, we get the roots like this. X is equals to minus 2 and x is equals to 3 plus 3 by 3 divided by 3 by 2. Okay, so this is what the first problem is. Let's solve the second problem. Okay, let's solve the second problem. Second problem is find the two numbers whose sum is 27 and the product is 180. The product is 180. Let's solve this. Okay, solution. We don't know the particular numbers. Okay, we don't know those two numbers. Okay, for that we can take x and y. Consider x and y. Okay, when we had these two numbers, we should get 27. When we do product, when we multiply these two numbers, we should get 180, right? 180. Let's consider this as equation 1 and this is equation 2. Okay. Now, uh, to solve the quadratic equation, we need only one variable, right? So, for one variable, from equation 1, we take y is equals to 27 minus x. Okay, let's take this as equation 3. You understand? Okay. Let's substitute. Let's substitute equation 3 into. Let us substitute equation 3 into. We get x into 27 minus x is equals to equation 2 is 182. You understand? Okay. Let's multiply this 27x, x into 27 is 27x minus x squared which is equals to 182. Okay. Let's shift by considering this. Let's shift this LHS to the RHS. Okay. When we shift this LHS to RHS, it is equals to 182 minus 27x plus x squared, right? Now, which is equals to, let's write in the quadratic equation form, that is x squared minus 27x plus 182, which is equals to 0, right? Then let's apply the factorization method here. Here there is no coefficient for this x squared, so we can directly find out the factors for this 182. That is, we can take 13 into 14, 14 is 182. So by adding these two terms we get 27, right? So here there is a minus, so we have to take minus 13 and minus 14, right? Now we can split the middle term here, that is minus 27x, that is x squared minus 13x minus 14x plus 182 is equals to 0. Okay, now when we take common of x, we get x into x minus 13, right? Then here we can take minus 14 common. Okay, yes, minus 14 common. Now we get x minus 13 which is equals to 0. Then we get, let's take this x minus 13 common, that is x minus 13. When we take x minus 13 common, we get x minus 13 into x minus 14, which is equals to 0. Now x minus 13 is equals to 0 and x minus 14 is equals to 0, right? Then x is equals to 13 and x is equals to 14. So these are the roots of the particular problem, that is second problem. Substitute this x in equation 3, we get equation 3 is y is equals to 27 minus, that is x is, we can substitute x as 13, we can get 14 here. Okay, then x plus y is equals to 13 plus 14 is equals to 27, right? When we had these two terms, these two numbers, we get 27, that is 14 and 13. When we multiply or when we do product of these two numbers, that is x and y, or the 13 into 14, we get this 182, right? 182. Or if I take from the equation 3, y is equals to 27 minus when I take this value, x is equals to 40, we get 30, right? So y is equals to 30. So then x plus y is equals to this x is 14, right? Plus 13, which is equals to 27, and when we do the product, we get this 14 into 13, which is equals to 180. So this satisfies these numbers 13 and 14 satisfies the given question, given problem, right? When we had these two numbers, that is 14 and 13, we get 27. When we multiply these two numbers 14 and 13, we get 180. So this is what the problems of the solutions of quadratic equations by using factorization. Okay, so this ends this lecture. Let's meet you in the next lecture. Until, take care, thank you, bye bye.